Hi everyone. Let's go ahead and take a look at the very last section of chapter 18, and this is going to be section 4, and it's called hemostasis. And this section is going to be broken up into a couple of different parts. So the first thing I'm going to do is I'm going to introduce you to hemostasis and the 3 phases and some background information that I want you to know. And then you're going to watch a separate animation that goes through those 3 phases of hemostasis. And then the very last video, I'll be back and I will talk about the elimination of the clot that's formed through hemostasis, and we'll also talk about some clotting disorders as well. So let's first define this word hemostasis, right? I'm sure you're thinking, well, what is hemostasis in the first place? You should be familiar with hemo because we talked about hemopoiesis, and that is, of course, it's going to be the root word for blood. And then there's stasis, which is going to refer to this stoppage here. So this is going in and taking a look at what happens whenever we have some kind of injury to blood vessels, and how are we going to go in and make sure that we don't lose too much blood. And there's 3 overlapping phases, and it's going to be the vascular spasm. This is going to be the very first phase where blood vessels are going to spasm and constrict to make sure that blood loss is going to be limited. The next phase is going to be something called platelet plug formation. This is where platelets are going to come in and they are going to start their whole function in the process of hemostasis. And the animation is going to kind of talk to you about their main function and the platelet plug formation, this kind of temporary stoppage that we have until this blood clot is going to be formed. So this is called the coagulation phase. Now don't get coagulation and agglutination confused. We talked about agglutination back in the blood typing, and agglutination is going to be where you have antibodies that are attaching to antigens, and they are going in and kind of making this network of cells. This coagulation is going to refer to a blood clot, and there's no antibodies, no antigens that are going to be involved whatsoever. So that's the main function here of hemostasis, trying to get this blood clot formed to make sure that we don't lose too much blood. Obviously, hemostasis is going to come into play when we have kind of smaller injuries, smaller bleeding injuries that are going to occur. Now, if you had a big bleeding injury, like a stab wound to the chest or something like that, this is not going to cut it very well. So, so let's go ahead and we'll talk more about what happens with a big loss of blood in the future chapters. This one is taking a look at what happens when you have smaller bleeding injuries like this. So the main thing is going to be this kind of making this blood clot right here. And the video is going to go through the 3 phases and then talk about how coagulation is going to occur because of the fact that you're taking this network of fibrin. Fibrins are going to be all of this kind of blue or teal color that you see. It's an insoluble protein. And that's what we are going in and trying to form is going to be that. So fibrin is going to come from something called fibrinogen. Hopefully you guys remember what fibrinogen is. Fibrinogen we talked about. It's going to be one of those plasma proteins that we talked about way back in the plasma chapter. What fibrinogen is, it is a soluble protein that does help with this whole blood clotting mechanism, but as you can understand, it's soluble, so it's a good precursor, but we need to make it into an insoluble protein. And that's one of the main things that's happening here at the very end of hemostasis and forming this blood clot, is to form that insoluble protein. And really what it is just a collection. A blood clot is really just a collection of erythrocytes, leukocytes, platelets, and proteins. The last step, so here are the different steps. These 2 are pretty simple. It's the last step that gets a little bit more complicated. And the reason why I want you guys to watch the video is it does a really good job at just summing it up. As you can see, there's a lot of different factors that are coming into play here in the coagulation cascade. And the the animation's good in the fact that it really just gives you the main ones that you need to know about, you know, the starting factors that you need to know about. And then really concentrating down here as to how do we make fibrinogen into fibrin. So that's why I want you guys to kind of watch that video. What's really interesting is that this whole blood clotting mechanism is actually going to work on a positive feedback mechanism. It'll talk about how, you know, the platelets work on the positive feedback mechanism until eventually a clot is going to be formed. Now, like I said, this is going to be good for lower blood loss, or not as much blood loss. If there's anything greater than 10% blood that's lost, then we'll talk about what happens, how the sympathetic nervous system is going to come into play, and you have these massive amounts of vasoconstrictions occurring, heart rate that's going to increase, your heart's going to contract harder. So we'll talk about what happens in the future chapters if something greater than what a blood clot is going to do. So go ahead and watch the animation, and then after you're done with the animation, we're going to talk about how to eliminate the clot. Once we're done, once the wall has been built, or the blood vessel wall has been built back up to and repaired, we're going to talk about how do we get rid of the clot, mechanisms in the bloodstream to make sure that we don't just, you know, our blood just doesn't clot whenever there's not an injury. And then we'll also talk about some clotting disorders as well. So until next time.